Okay, so we're looking at inverse and direct proportion, and we're looking at reviewing this topic area. So key things to remember is that direct proportion is when you have a relationship that goes through 0, and when we're comparing the two variables, which we'll call x and y, then it's always a straight line relationship where the gradient is k, the constant of proportionality, and the relationship is always going to be y equals the proportionality constant times the x value. If we've got inverse proportion going on, so this one was direct, if we've got inverse proportion going on, then as one variable increases, the other decreases. So we have, as the x variable increases, the y variable decreases, and that always produces a relationship where we do the proportionality constant divide by the other variable. So we need to have these kind of pictures in our mind, and these two relationships: direct proportion, proportionality constant times the variable; inverse proportion, proportionality constant divided by the variable. So let's have a look at the questions and check out what's going on. So y is direct proportional to the square of x, so it's direct proportion. So y is going to be equal to k times x. Now it says square of x, we've got to be careful, so it's x squared. There's kind of a step process to this, guys. So all we've got to do now is find the k value, and then when we get the k value, rewrite the formula so that we have the relationship to then work out missing values. So we always rearrange to get the k value. So k equals, well, it's k times x squared here. So the x squared is going to move across the equals by the opposite operation of divide. So k is going to equal y divided by x squared. They've given us some values to work with. So they're telling us that this relationship will hold when y is 5, x will equal 4. So we replace the values for y and x, and we find then that the proportionality constant in this case is 5/16, 4 squared being 16. Always then write the relationship with the k value replaced, so we know that y is equal to 5/16 of the x squared. That's your formula, and you should really be in the habit of thinking, well, I know how to get the y value, the question may eventually ask me to get the x value. So I should also be thinking about rearranging this to be x equals as well. So I have the two formulas to work with, one to calculate the y value and one to calculate the x value. This particular question wants you to find the value of y. So we're going to say y equals 5/16 times, well, they're asking us to square the x value, so it's going to be 8 squared. So that gives me 5/16 times 64. Well, what we should realise here is 64 divided by 16 is 4, so this becomes 5 times 4, which equals 20. So the final answer here will be 20. As I say, the 64 cancels by 16 4 times, 16 cancels by 16 once, 5 divided by 1 is 5, times by 4 is 20. The next question is asking you to think about working with inverse proportion. So this time the relationship is going to be y equals k over the variable. So what have we got? So we're doing the proportion of the square of the distance. So it's k divided by d squared. So I have to be really careful that we always kind of identify what's happening to the variables. So it's k divided by d squared. Again, always rearrange to get the k value to rewrite the formula. So k is going to be equal to y times d squared. Divide by d squared here, the d squared moves across then by timesing. So k is going to equal, well, they've told us some values, and it's not y, that's my fault. Should always replace y with whatever the variable is in the question. So they talked about L, so it should be L equals k over d squared. So this y should be L. So k equals 2 times the d squared value. So d is 10, so d squared, so k is equal to 200. As I say, get into the habit, always write then the formula that connects the two variables. In this case I call it an equation, but really it ought to be called a formula. So L equals 200 divided by the d squared value. So that's the relationship. It then wants you to work out the value of L when D is 2. So L equals 200 divided by 2 squared, 200 divided by 4, so 50. So the answer here will be 50. It then wants you to calculate the value of D when L is 8. Well, we know what the relationship is for L. We know it's 200 equals D squared. They want you to calculate the value of D, so that means we want D equals. So in other words, we've got to rearrange this to make D the subject. So we know what D squared is going to be. D squared times across there with L. So D squared is going to be 200 divided by L. Take that across by timesing, and then the L comes across by dividing. So we have D squared equals that. So D must be the square root, the opposite of squaring, square rooting. So the square root of 200 divided by L. So D is going to equal the square root of 200 divided by 8, and that's going to be the square root of 25, which we recognise is either 5 or negative 5, but in this situation we'll just put down a positive solution. So the key steps are: find the K value, write the formula, put the numbers in to find the missing values. If you need to, rearrange the formula to get the new subject, and then put the values in again, and you work out those. So let's look at another question. So here we've got direct proportion again, and it's the square root of P this time. So direct proportion is always going to be of this form. So we've got our straight line going through 0. So we just replace the y and the x with variables of the question. So in this case we've got w is equal to k times the square root of p. So as always, step 1, find the k value. So we need to rearrange this to be k equals, get the subject. So w divided by the root of p. And they give us some values to work this out. So we know that when w is 12, the p value is 16. So k is going to equal 12 divided by 4, 3. As always, write the formula. So w equals, k value was 3 times the root of p. So when they're saying express w in terms of p, they just mean what is w equal to, with p on the right hand side. It then asks us to find the value of w when p is 25. So we're just going to use the formula we found that says w equals 3 times the root of 25. So that's 3 times 5, 15. It then says it wants the value of p when w is equal to 21. So that means we want p equals. Well, again, it's this idea of making p the subject. So we have w equals 3 times the root of p. So I'm going to divide by 3 first. So w over 3 equals the root of p. And I want the opposite of rooting, which is squaring. So we finish with p is equal to w over 3 all squared. That then allows us to find the value of p by putting the value of w in. So we find that p is equal to 21 divided by 3 all squared, or 21 divided by 3 is 7, and 7 squared is equal to 49. So the answer here will be 49. So in this question it talks about an example of the real application of direct inverse proportion, and that's about this idea of looking for a pattern. So basically, as always, we would have plotted this data on a graph if we were looking for the relationship, and we would have plotted t against h, and basically if we look at this carefully, 210, 562.5, 690, it's not a straight line, and it's not going to go through 0 very easily, so it looks like this relationship isn't even worth looking at. So we are looking at something like this, which basically means that we've got to look at what happens when we plot t squared against h, or we've got to look at what happens when we plot t cubed against h. If one of those produces a straight line going through 0, then it's going to be that relationship. So that's our kind of thought process. Which of these is going to produce a straight line going through 0? And what we need to do then is we need to rewrite this so we're going to have t squared values instead. So we've got t squared, well that's 2 squared is 4, 25 and 36. H remains the same, so 10, 62.5 and 90. So we're thinking that we'll try this one first. So remember, for every one across we go with the k value. So in other words, to find the k value. So let's see what the k value would be for these. So k is equal to h divided by t squared, because we think the relationship is h is equal to k times t squared. So when we do this, we end up with 10 divided by 4 is equal to 2.5. We end up with 62.5 divided by 25, which is 2.5. And we end up with 90 divided by 36, which is 2.5. So every time we do this division of the variables, we end up with the same value. So in other words, we've got a constant value going on here. Therefore, it's a straight line relationship going through 0. That tells me straight away then that the relationship between these variables that works is h is proportional to t squared. Okay, so that's the way you kind of think about this problem. I mean, I should have checked by doing 10 divided by 2, which is 5, 62.5 divided by 5, 12.5. Straight away doing the straightforward division of those didn't give me the same constant value. So this relationship just didn't work. Doing t squared, I found I got a constant straight away, so I don't need to check t cubed. I already know the relationship. We've then got this question, which talks about y is inversely proportional to the square of x. So y is going to be k divided by the square of x. Remember, for inverse proportion, the relationship is suggesting as one variable gets bigger, the other variable gets smaller, and that relationship is always going to be y is k over x if we know it's going to be inversely proportional. So as always, step 1, find the k value by rearranging. So divide by x squared changes to times by x squared when we move it across the other side of the equals. So to get our k value, we've got some values here for y and x. So k is equal to 3 times 2 squared, and that gives me 12. As always, now put the k value back into the original relationship to get the formula that connects the y and the x squared. So we're saying that y values can always be found by doing 12 divided by the square of x. So it says find the value of y when x is 4. So y is equal to 12 divided by 4 squared, and that's 12 divided by 16, half down, half down. So we can see that this is going to be 3/4 or 0.75. So the y value is 0.75. So that's a summary of questions that you might face at GCSE exams involving direct and inverse proportionality and finding the formulas and relationships between the two variables. Hope it's useful.